So this question is about the change of momentum of a gas particle in a collision. And my way of approaching this would be to look at what my starting momentum is for the gas particle. So my starting momentum is mv in this direction, and then my final momentum is of the gas particle is in this direction. So what is the change in momentum? Well, the change in momentum is the vector that links those two. So the change in momentum is this vector, which is horizontal to the right, which makes sense because the vertical motion does not change. The vertical motion is still the same. If we ignore the horizontal component, the vertical motion is still the same. And we have a vertical wall that can only apply a force in the horizontal plane. So that makes sense. So this gives us the correct answer, where this is mv and this is mv. And then working on that. Now, it doesn't look like any of the diagrams, although only diagram B has the change in momentum being equivalent to this. So it's equivalent in size. And I think intuitively, I think this is a much more sensible way of approaching it in terms of my diagram of seeing what's happening. Diagram B, we have the change in momentum. So we have a change in momentum going through. This is the change in momentum that happens to the, well, we can look at it, I think it makes sense to go this way. We can look at it where it ends up going like this. So that's added to it. Then we have changed it from its original momentum, which is in the opposite direction to this one, from this to 0, which is a change in momentum of this value. And that ends up with the same delta mv. But I don't think that's as clear and obvious, although you end up with the right answer. So I would be doing it this way and then looking to see which way my delta mv is and getting it from that.